Hey guys, so welcome to this video where we'll be looking at the any and all operators in TSQL or Transact-SQL or SQL Server, depending on how you refer to this subdomain of query language. In part 21 of this Transact-SQL playlist, we had looked at combining multiple return values and filtering data based on these values that we had combined using the in operator. So I'll just link to that in the top right corner of the screen. It's somewhat related to this video, so you can just, if you're not sure of how the in operator works, you can just check that out. Today we will look at two similar operators, the any and all operators. And so before we dive into the any and all operators, let's just take a look at some of the sample data tables that we'll be using for this demonstration. So we have basically two very simple tables that we'll be demonstrating on. We've got a managers and an employees table. So these are basically the managers in a company and the employees in a company. And both tables have just a name and an age. So you can see we've got 6 names in each, and I've just kept this purposefully very simple, minimal table, so it's easy for you guys to understand. So that's a bit about the tables that we have for you. Now let's just set up the environment so that we can show you the demo. So I'm on a Mac, so I'm using Azure Data Studio to use SQL Server. If you're on Windows, you can use SQL Server Management Studio, which is I've got installation guides to both of these depending on what OS you're using, and I've linked to them in the top right corner of the screen and the description in the video below. And apart from that, I'll also link to a GitHub repository in the description below that will have the sample data that we're using in this demo, and also the exact any and all queries that we'll be using in this demo. So you can just copy and paste all the data into whatever SQL Server tool that you're using, and you can follow along with this demonstration. So let's dive into the any and all operators. Coming back to the tables of data that we had, you can see that we have the managers and the employees table with their name and age in both the tables. So suppose we wanted to answer a question: are there any employees in the company who are older than all the managers in the company? So when you're looking at the table, when there's such little data, like in this case, you can sort of just visually compare, and you can see that in the employees table, we've got Neda, who's 83 years old, who is older than all the managers. But transforming this into a query when we so that we can use it on larger data sets where it's not possible just to visually verify, that is when the all operator comes into use. So let's just look at the all operator. So I've put the syntax down for the all operator, and it's basically just select a column name from table name, where a column name, and then you use an operator all, and then inside a bracket you can use a subquery to specify the return values that you need to compare against. So it'll become more clear to you once we dive into the demo. So let's just dive right in. So as you can see, I've got a managers and an employees table. I'll just query both of them so you can verify that they are the same tables as we have shown you in the slides. So now if we wanted to use the all operator, what we would do is we could do select star from employees where age greater than, and this is where it gets tricky. So up till now, we're basically returning all the data relating to pertainees where age is greater than a certain condition. And what is that condition? That condition needs to be the values of the ages of the managers who are also in that company. So here we can bring in another subquery which returns the ages of the managers from the company, and where we can do, and it's important to specify the all keyword here. So where we can do where age greater than, where age greater than all, and then in brackets we specify the subquery. So the subquery here in this situation to return the ages of the managers would just be select age from managers. right? And then you can put a semicolon at the end of that. And when we run it, we should just see neda because we had visually just verified that. And you can see that is what we are returning. So again, just to run you through what happened, we are till, so I could say sort of till here, this part of the statement, we are just specifying the returning of all data from the employees table where age is greater than a certain set of values, and those set of values has to be the ages of all the managers in the company. So how we do that is we specify the all keyword. The all keyword basically makes sure that this age from the employees table is greater than all the ages that is returned from the managers table. So there can be, the data that is returned will have to be greater than all the ages from the managers table, not just any age, which is what the any operator is, and we'll come to that slowly. But just taking you through this query again, we can see that we get Neda, who's 83 years old, who is older than all the other managers in the table. So suppose we wanted to answer another question, which was list the employees of the same company who are older than any one or multiple managers in the company. Or basically, how I could rephrase that is, they are older than at least one manager in the company. So we can answer this using the any operator and a subquery. So let's just put that into a query format. Again, it begins the same way. Select star from employees where age greater than, and here's where the difference comes. We use the any operator here and then specify the same subquery which returns the ages from the managers table. Now, the difference between the any and the all operator, I think it would have become clear to you now, is that when we specify the any, what happens is basically that this age just needs to be greater than any one value that is returned by the subquery from the managers table. Whereas in the all operator, it has to match the criterion for all the values that is returned from the manager subquery. So the any operators, as you would probably suspect, would return more values, and it does. It returns 5 values from the employees table. We've got 6 employees, but it returns 5, and what that's telling us is there are 5 people, 5 employees in the company who are older than at least one manager in the company. And there should be a 6th employee, but he is younger than all the managers in the company, and hence his data hasn't been resolved. Just another thing for you to know is that in this example we had used the greater than comparison operator, but you can use any of the comparison operators. I put a slide up here that lists all the operators that you can use, but you can use any of the comparison operators in the same position that we had used the greater than operator. So if you wanted to find younger than, you would just use the less than operator. Or if you wanted younger than and same age, you could do less than and equal to. So in that sense, it's quite a useful operator to know, or set of operators to know, since there are 2, the any and the all. But that's it for this demonstration. Thank you guys for watching. Don't forget to like this video, comment if you need some help, subscribe to our channel, hit the bell icon so you're notified when we make a new upload. And once again, thank you guys for watching.